Hi there, and welcome back to part 2 of this video. Today we're going to be discussing another question involving indices, but before I jump right in, I kind of want to recap a bit of your knowledge. So, let's take a very special case where we get x times x. I know it's simple, most of you should know what it is, but when you multiply two algebraic elements together, we add them as powers together. i.e. so x times x will equal x squared, or two lots of x multiplied together. Now, if we carry on and continue in this way, you should be able to see that the pattern repeats. So we have x times x is x cubed. Now, what happens in the situation when I get x squared times x squared? Well, you guessed it, we add the powers when we multiply. So we get x to the 4. But this is just saying, right, x squared and two lots of them. So we know from this rule that this must also equal x to the 4. So here we're starting to discover that when we have a power of some sort inside a bracket and all to the power of some number outside the bracket, we end up multiplying them together. So for a quick exercise, we could say x to the 3 all squared. Well, we know, maybe let's do it a bit pedantically and a bit long, but x cubed times x cubed. And we know that these rules apply that we can add the powers together. So it's x to the 6. So here, x to the 6. So what we've done essentially is just multiplied the number on the outside with the number on the inside. So that's what we need to remember for these kind of rules today. Now, albeit I'm making this very simple. I'm not overcomplicating anything. And if you wish to ask any questions, feel free to leave comments below and I'll answer it a bit more specifically. But let's go back to answering this question now. We have 4y cubed to the minus a half. Now, I know I want to be using this multiplication idea where we've got the minus a half on the outside and I want to be multiplying it with the powers on the inside. Now, I've circled the 3, but that's not the only power that we've got inside. I can write this as 2 squared y cubed to the minus a half. Now, when I multiply in, I have to multiply both. I have to multiply that and multiply that. So I'm going to have 2. Now the power is 2 times minus a half. So 2, let's do on the side, 2 times minus a half. Well, 2's cancel and I get a minus 1, okay? You should know what that is, but I'm just doing a bit long anyway. So 2 to the minus 1. Now I'm going to do the same thing to the 3. What's 3 times minus a half? You guessed it, minus 3 over 2. So that's y to the minus 3 over 2. Now, here it says we want it in this form, which is ay to the to the p, and a and p are constants. Constants are numbers, okay? It's just easier to think of it like that. So a, by inspection, is 2 to the minus 1. And how else can we write that? From a previous video, if I remember right, that was done a few days ago, where I say when you have a number raised to the minus 1, essentially it's 1 over that number. It belongs downstairs. That was the analogy I had then. Now, y to the minus 3 over 2. So clearly p by inspection, let's try and get another color here. Let's get a red. P is minus 3 over 2. And this is done. Okay? Right, next question. Now, this here is very similar to part 1 of the indices videos, but done a little bit more, slightly more difficult question. Let's get started. It says, note that it says without a calculator. So, for all you people who want to try and cheat, you're not allowed. So, let's do this in stages. Now, whenever you get an indices kind of question, a fractional indices question, I want you to do it in this particular order. And I'm going to write down the order. First, I want you to deal with any negative powers. That is, if there's a minus on the outside, if you've got some number all to the minus 2/3, say, I want you to bring the minus in. So let's say the number's here. I want you to bring the minus in and then deal with the fraction after. So the first step is dealing with the negative power. The second step will be dealing with the fraction, the denominator of the fraction. So in this case, if we're going to use, let's use minus 2/3 for an example here. I want you to do the minus power of the minus 1 first. And then after you've done with that, okay, you'll be left with a 2/3. And then you'll get this number, whatever this number may be. Then you will deal with the third. You'll bring the third in, i.e. that will be a cube root. And then you're left with a square on the outside. And then after, you deal with the square. So lastly, or say thirdly, third, deal with squaring. Okay? Now I'm going to leave that to a side now, and you're probably going to think, oh, what does all this mean? Give me an example. And don't worry, I'm about to give you an example. So let's do A first, as initially discussed. Now notice there's no minus here. So if there is no minus in the power, let's highlight it. If there is no minus in the power, we go to second place. So second place is dealing with the third or the half, whatever the rational power may be. So I think we did this in a previous video, but I'm going to go over it again. 27. That's right. I'm just going to write it out. Now I want to deal with the third bit first. I want to make it smaller by cube rooting. Remember, recall, a third is the same as cube rooting that number. Now I want to cube root 64/27. So what's the cube root of 64? Well, 4 times 4 is 16, times by 4 again is 64. So that's 4. What's the cube root of 27? Well, before I mention this, most times in GCSE, they're very simple numbers. They're either going to be 3, 4, or 5. You'll not get like 9, or the cube root of something is 9. It's just too much. It's too big to compute. So the cube root of 27 is 3. Now, once we dealt with the cube root, we can essentially eliminate that 3 in the denominator. And then we're left with a square, which is simple. 16. Square root of 3 is 9. And that's done. Now, I'm just going to rub this out for some space so I can keep the right hand side available. Let's do 64 to the 27, 64/27, sorry, to the minus 2/3. Now, we have a minus there. And typically, what I've been saying to you, when I say, what's 3 to the minus 1? You say 1/3. Now, really, what is going on is that you can kind of think of every number, every integer, as 3, or as that number over 1. So we're using 3. So let's try and use 3. So the integer 3 can be written as a rational number, and by rational number I mean a number over a number, as 3 to the 1. Likewise, 4 can be written as 4 over 1. Sorry. So every integer can be written as that number over 1, because when you divide by 1, you just get the same number. So what I'm kind of doing when I said in previous videos, when you see a minus 1, it belongs downstairs. What I'm actually doing is flipping the number. So you can kind of think of, well, what I'm doing is, well, it's 3/1 to the minus 1, and then I'm flipping it and I get 1/3. So essentially that's what I'm doing. I'm actually reversing it. So i.e., if we were to do 4 to the minus 1, you would know it's a quarter, but I could write it as 4/1 to the minus 1. And then what I'm doing now, again, is flipping it. So I'm doing 1 over 4. Now I'm introducing this idea of flipping so that we can come to do something when we have a negative power and we have a fraction that we need to deal with. That's not a 1. In this case, the denominator at the bottom is 27. So, but we know if I'm dealing with the negative power, so I'm just going to, for now, deal with the first bit, which is 64 over 27 to the minus 1 we can think of, right? And then we're going to deal with the 2/3. You can think of it like this, like a huge bracket with a 2/3 outside. But I'm going to do it in bits. And we can just keep in the back of our minds that there needs to be a 2/3 power we need to implement to it. So 64 over 27 to the minus 1. What do we do when it's to the power of minus 1? We flip the number. And because it's already in a fraction, it's very easy to flip. Instead of it now being 64 over 27, we're going to get 27 over 64. Okay, if you feel like you want to rewind the video and just see what the operation of minus 1 as a power does, feel free to do so. So we're on 27 over 64. Now I said to keep in mind 2/3. All that's happened now is after I've dealt with the minus 1, after I've dealt with the minus 1, this negative number disappears and we're still left with 2/3. But at this stage, we go back to our operation second and third. So the second thing we have to do is deal with the cube rooting, or in this case, the cube rooting, so we can get rid of the denominator of the 3 of the power. So what is the cube root now? So let's do it a little bit longer. Cube root of 27 over 64 all squared. Now, if we look, I mean, you probably think, well, a part B question leads from a part A. It does, really. At this point now, we've already done it. So I'm doing it again, essentially. At this point, we've done it because we know what part A was. This is the same, well, no, it's not the same question as part A, but the operations are very similar. We could have flipped it, yes, for those students who could just recognize it straight away. We flipped the number above, but I think we're going to just, for this case, be a bit slower and go through the whole system a bit more pedantically. So the cube root of 27 over 64, well, we can do it individually. So the cube root of 27 is 3. The cube root of 64 we discussed was 4. And then we have that all squared. We get 9 over 16, which is essentially just the reverse, the flip of the first question, part A, which asked us what's 64 over 27 to the power of 2/3. So that minus, now you can start thinking to yourself, every time you see a power of a minus, I'm thinking of flipping the fraction upside down. Instead of having 64 over 27, I can flip it, and by flipping it, I get rid of that minus power. And then when that minus power goes, we can start dealing with the second category here and the third category here, i.e. bringing the cube root in first and then squaring after, or whatever the number may be. Most of the cases, you're going to get 2/3, but I've seen